In this video, we're going to be talking about the difference between continuous and discrete data. Continuous, this is when the data includes an uninterrupted list of numbers from the first to the last value. Graphs would include all the points and everything in between. It is the set of all real numbers. The set of all real numbers, thus creating a graph that would be connected. Okay? So basically, this is going to create a line. So right here, it's going to create, let's see if I can write on this. It's going to create a line. That's what continuous data is. If I were you, I would highlight this right here, that it is a set of all real numbers. Examples of continuous data: time. You have to go through every minute of every day when you talk about time. You can't just skip to, if you have a party at 8 o'clock and it's 2 o'clock in the afternoon, you just can't, poof, it becomes 8 o'clock. You have to go through every minute of every day. So you've got 1 hour, 2 hours, stuff like that. And then you have all the minutes in between. Temperature. You know, you come to school, you get up in the morning maybe, and the temperature's 65. Then when you leave, it's 103. Well, it didn't just magically appear to be 103. It had to be like, it went from 65 and it increased and maybe went to 85, 85.9, 85.99, 85.99999999999, 85.999999999. Okay, you could just keep going on and on and on with all those numbers, and it does go through these numbers as it gradually increases. Speed is the same way. Distance, volume, age, height, weight. Okay, all of these you continually increase, and you go through every bit of the pounds and every bit of the numbers. Now, I want you to go with your calculator, and I want you to graph 2.5x plus 2. Okay, so we're going to go on to our calculator. Let me see if I can pull this up here. Let me pull this over. Go to my calculator. I'm going to go to y equals 2.5x plus 2. And then press graph. Well, what do you see? You see a line. You see a line with all the points, all the numbers, and it's just a straight line. Let's see if I can get the next one up here. Now, if I said we're going to use the trace button and we're going to list some of the ordered pairs. So I'm going to press traces right here next to your calculator. The first point I see is 0, 2. So if I go over here, I've got 0, 2. And let's go and let's find another number. So I'm going to press my arrow key. There's a bunch of decimals. So let's go over here and let's put 0.2127, comma 2.54. Okay, so now it says, is it possible to list all the ordered pairs? Well, if I keep moving the arrow key, it's going to keep giving me numbers, and I can keep going and going and going and going and going. Those numbers will continue. If I told you that that's what your assignment was, to write those all down, would you be able to do it in a class period? No. We can't list all the possible ordered pairs. Let's see if I can erase this here. You can't list all the ordered pairs because that would take forever. It goes on forever and ever and ever. Okay, so let's see. Let me go back and play the show and go back to the beginning, because I wanted to be able to use a calculator, but I couldn't do that. Let's see. Give me some moving through. Okay, we already went through and talked about that, and it's not possible to have all of them. Well, when it says to describe the domain of a function, let's see, the domain is the x. Well, if that line continues on and on and on, You're going to have all the positive numbers, all the negative numbers, all the whole numbers, decimals, fractions, all of that. But what we're going to call this is it's a set of all real numbers. So when they ask you to describe the domain of a function, you are going to write, whoa, that's not it. Let's see if I can get there we go, all real numbers. That's what you would write. You're not going to give a specific thing. You're going to write all real numbers. Another way to go through and write this is the sideways 8 is negative infinity to positive infinity. Domain of the function. The function is something that the calculator sees. It does not apply meaning to the numbers. So to describe the range of the function, the range is the y, that y number. It's how it goes up and down. Okay, remember range is up and down. Again, it's all the positives, all the negatives, whole numbers, fractions, decimals, all of that. When they ask you to describe the range of a function, you are going to write all real numbers. Or you could see it written as negative infinity to positive infinity. Now, discrete data. Discrete starts with a D, dots start with a D. So discrete data, when we do that, remember the continuous was a line, the discrete is going to be dots. It's kind of like a scatter plot. This is data which only includes specific numbers, graphs that would only include ordered pairs, which are specific locations. Thus, the graphs would not be connected, but only points. So basically, dots, discrete. Another way to remember. Examples of discrete data, CDs. Look, I am not going to say, hey, go to Walmart and buy me 1.5 CDs. Really? What are you going to do, cut it in half? Well, then another thing is money. Okay, so people go, well, you can have part of $1. Well, think about this. If I asked you how many dollar bills do you have, would you say you had 1.5 dollar bills? Can you take a dollar bill, tear it in half, and that means 50 cents? No. So you either have $1 bill, like 1 $5 bills, 2 $5 bills, 3 $5 bills. Jelly beans, tickets. Okay, seriously, if I want to go to a Lady Gaga concert and I buy one ticket and I decide I want to take a friend with me, can I tear that ticket in half and then that means 2 of us can go just for the first half? No, you've got to buy one ticket for each person. People. Okay, we are not going to have a party and invite 2.5 people. I mean, what are you going to do? You invite Joe and Sally and then the leg of Bob? I mean, you can't have half of a person. So, for example, on an amusement park, Gary can buy tickets for the ride for $2.50 each, and his cost for entering the park is $2. Okay, look at this. Let's think about it. This is part of what we've already talked about. Which number would be my coefficient, and which number would be my constant? Okay, I want you to think about that, and we'll come back to that in a minute. The next thing, what about my independent and dependent? What is my x and my y? My x is my independent. So what is my x talking about? My x is going to be the number of rides. And my y is going to be the total cost. Remember, dependent is always total something. My number of rides is x. Now, why is this discrete? Well, think about discrete has to be whole numbers. Can you go on part of a ride? So let's go and look at this. On my equation, we're going to use the exact same equation. Now I said which number was my coefficient and which one was my constant. Okay, let's talk about this right here. Let's find my number here. All right, this number right here, the number that is attached with the x, that is my coefficient. Okay, it's not the first one, the last one, it's whatever is attached to my x. This one that is by itself a one-time charge, this is a constant. Well, why is that the constant? Well, because if we went to go into this amusement park, this is the cost to get in. This is a one-time charge. So to get in the gate, you only have to pay $2. Now the coefficient over here, on the other hand, this is what you have to pay for each ride. And we already said that the x, is the number of rides. Okay, number of rides. Now, a reasonable domain. Domain is the x. If x is my number of rides, look at this right here. How come they give me 0, 1, 2, 3? Okay, well, can I ride 1.5 rides? Can I say, ooh, I only have enough money for 1.5 rides. Can you just take me up to the top and let me jump off? No. Can you just say, let me go around the merry-go-round 3 times and jump off? I'm done? No. So they have to be whole numbers. The other thing is, can you ride -2 rides? No, you cannot. So a reasonable domain, you're talking about the number of rides, 0, 1, 2, 3, up to a reasonable number. Up to a reasonable number is because you're not going to ride 1,000 or a Google or a billion rides because the park is going to close. Or you'll throw up between one of the two. It doesn't matter. But you can't honestly ride and keep riding until you ride 1 billion rides. Reasonable range. What is the smallest amount you have to pay? Range is the Y. Y is the total cost. What is the smallest amount you have to pay? You have to pay $2 to get into the park. Okay, and then after that it's $2.50 for each ride. Again, you're not going to just spend $6 because it's not going to get you on a ride. You're either going to spend $2, $4.50, $7, $9.50. Okay, you can't even spend $0 because you have to get in. So your reasonable domain is the total cost to 4.57, 9.5 up to a reasonable number. When you go to plot the points, right here you're going to plot them and you have number of rides and these are dots. This is what our graph is going to look like. It's when you apply the rules or what the word problem means to the actual numbers.